Okay, well, welcome to this webinar, Best Practice Techniques for Using FME. My name's David Eagle, and this session is one of our webinar series that we've been running for the last couple of years now. We've had a number of sessions in the series that are all available over on YouTube to browse at your leisure. Thank you for joining us live. Gives you the opportunity to ask some questions and perhaps direct the progress of the session depending on some of the things that you might ask. I've asked if you could please mute your microphones. There'll be opportunities at the end to ask plenty of questions. Throughout the session, feel free to post questions in your chat window. My colleague Hayley will relay those to me later on in the session so that I can answer them for you. So feel free to ask any questions you've got. Focusing today on best practice, using the context of a real world project that OneSpatial conducted towards the end of last year, looking at a capability called the Object Editor Adapter that is a process that sits within the Ordnance Survey. But that project drew out a lot of very important best practice techniques, some of which I'm going to share with you today. Focusing on a few things like harvesting information from your FME workspaces, actually understanding what transformers, what versions of transformers, what readers and writers are included in your process, and why that's important. We're going to look at using FME to test itself, so making sure that processes that you've built continue to give the same results throughout the life of a particular process. And then looking at some particular tips and tricks for process efficiency and best practice techniques around annotation and system performance. And then later on in the year and early part of next, we'll be looking at a webinar to focus specifically on performance of routines and hardware setup and that kind of thing. So that will be a partner webinar for this one. Very briefly, OneSpatial, we've been around for a number of years now, and we focus on data quality and a number of capabilities in the GI industry around some of our technology partners. We'll be focusing on the relationship that we have with Safe Software today around the FME product. We've got a number of offices headquartered in Cambridge, where my colleague Hayley is sitting at the moment, and we've got offices in France and Belgium, Australia, and also in Ireland. We've got a very broad customer base. We're focusing on looking at the Ordnance Survey briefly today, but some of the other national mapping agencies that we work with are listed there, as well as some private sector, some utility firms, and also central and local government that we're working with at the moment. A number of different industry sectors have a number of our consultants focusing on some of their particular projects. We have a number of different capabilities around certain technology stacks. As a very focused Oracle organization, we have a number of Oracle DBAs. We're very focused on FME as a product set, and have globally quite a few certified staff. Myself, David Eagle, I'm a certified FME professional and trainer, and I'll take you through some of the capabilities of the FME toolset today. Safe Software themselves are an organisation that make FME. FME is the product, Safe Software is the company. And they've carved themselves a very unique niche in that they have a tool set that connects to many, many different software environments and format environments. Some of them are listed just there, and some of them are file formats, some of them are databases, some of them are cloud-based. But FME allows you to get data between those environments, or even between the same environment. It's not necessary to do a translation. You can just restructure the content and load it into the same format again if you wish. There are three main products from Safe Software: FME Desktop, FME Server and FME Cloud. We're focusing really on FME Desktop, but many of the capabilities that I'm going to show you do translate into more performant processes on server once you publish your workspace to the server environment. So that's important. They also translate into the FME Cloud product, because of course FME Cloud is effectively FME Server on a cloud platform. So the beauty and the capability of FME Server and FME Cloud is that they run FME Workspaces. So just a little bit of an understanding of the technology stack there. We've been resellers since 1998. We have support for all of the products, and we have a number of different services that we carry out for our customers. One of those is really around product evaluation, and that's largely what these webinars are also designed to help you with. Help you understand how the product works, how you can best get benefit from it, and help you evaluate the toolset quicker if you haven't bought it. But also if you're a more advanced user and have been using FME for a little while, help you discover new capabilities in the product that you might not have seen before. So moving briefly on to the subject matter of this session, the customer that we worked with is the Ordnance Survey, and those of you that are dialing in from the UK will be very familiar with the Ordnance Survey. Those of you outside of the UK have probably heard of the Ordnance Survey anyway, because Ordnance Survey are being very involved with the wider National Mapping Agency community with their organisation, Ordnance Survey International, which is spreading the word about the work that the Ordnance Survey are doing. Ordnance Survey has been around for a very long time in its different guises, and it was very much a department or a division of the military, effectively, the Board of Ordnance, because a lot of the point of the mapping was that you were able to see military installations and manage those. This is a link to the British Library's online mapping gallery, and here you can see some rather old mapping of St Michael's Mount, and you can see that the focus here is on military installations. The fact that there are different sized weapons on St Michael's Mount at different angles, trajectories, and locations with different sizes of ordnance. So one of the very early maps there on the British Library's map gallery. Today, the Ordnance Survey is a self-financing part of the UK government, and many of us in the UK use all sorts of Ordnance Survey data, whether it's master map or whether it's open data products. The toolset itself lends itself to reading and writing many of these Ordnance Survey products, and that's really where I want to start focusing my attention. At the Ordnance Survey, they have a system to manage the data, and it's generally referred to internally as the GDMS, the Geospatial Data Management System. It's a solution for managing and maintaining their data, and it allows separation of individual products at the Ordnance Survey so that they can be managed and ultimately distributed to us, the users. Those data sets go through all sorts of different validation. There are constant updates to the data, with over 650 real data editors who are individually updating the base map. Over 500 million geometric features sit within the database environment, and there's over 4,000 data maintenance jobs each day. And this last statistic gives you a hint at how many times the workspace that I'm going to go through with you actually runs during its lifetime. So it's a very frequent process that runs throughout the day. GDMS production system has a view that looks a little bit like this. The Maya database environment is an Oracle environment in which all the data is stored and managed, and I'm going to be focusing on this section here, the Object Editor Adapter, which effectively is an FME workspace that extracts the data from GML to an Esri personal geodatabase. so that it can be used in the OS's object editor mapping environment. And this is what the surveyors and all the editors, different contractors, use to manage and update the base map before it then routes its way back from a checked out data environment back into the master data environment in Maya. I don't really want to focus on that anymore. I want to get into the nitty-gritty of the session to look at the FME capability, but it's GDMS is made up of a number of different off-the-shelf products that are brought together, and I'm going to be focusing on the specific object editor adapter, which effectively takes the data from the Oracle environment and puts it into an understandable structure that can be managed and manipulated within the editing environment that the Ordnance Survey use. So we were enlisted to help them out with a particular project which was to update the object editor adapter process, and it had a number of goals for this. The main one was to make the workspace that ran much more practical to maintain and update. There were some schema changes to the base map pending, and it meant that it was necessary to get a better understanding internally of the process. We also needed to look at upgrading the process where possible. So at the time, it was when FME 2013 was around, but we needed to be mindful of the future and aware of what's coming in the new build so that we could architect the process in as much as possible to be aware of that. The original process was built in FME 2009, and many enhancements happen in the IT industry, let alone in the FME product, in that period of time. So we were looking to make sure that we could bring in some of the new capabilities to the process. So we also wanted to hopefully improve efficiency of the process. There was a little bit of redundancy in the process that we could hopefully try and architect out of it. And they were the three key things that we wanted to deploy. And this project is really focused at taking an existing FME workspace and making it better, bringing in some of the new changes in the product and trying to deploy best practice on that process to make it much simpler to manage in the future. It's definitely the case that in some scenarios you might want to say, well, if it ain't broke, then don't fix it. But there is certainly in this case there was a number of significant issues that we needed to try and address to make the process more performant, but also make it more manageable and maintainable. And the relevance of the things that I'm going to show you is not just to revising an existing process. Some of this knowledge will help you understand how best to start building a process in the first place, and that's really the focus. A few things that were obvious challenges was that the workspace itself was so large that it took a very long time to open it. I actually opened the process well before the webinar because it takes too long for that to pop up in Workbench, and that is a challenge, especially when you're reading it over a network. And as this process runs on FME server, a significant proportion of the process's time was actually opening and closing the workspace, which isn't ideal. So trying to get that to a more performant size was one of the aims. And also the file size was a little bit of a challenge. If I just show you the workspace on disk, you can see that it's nearly 60 megabytes in size. Now, those of you who have used FME for a little while and have signed into this session will know that it's actually quite hard to get an FMW file much bigger than a few kilobytes or a few megabytes, let alone nearly 60 of them. So you'll see why in a few moments. But the process included quite a number of transformers. That's a screen grab of the process, and actually if I just bring in the real thing in, you can see that some of the problems are very obvious straight away. This is the workflow, and you imagine trying to unpick what this is actually doing is a little bit of a challenge. You can see there is a little bit of best practice deployed in here. There are some annotations around the workspace, but ideally we'd like to try and make that a little bit more detailed You can also see by the way that the process is structured that there's perhaps quite a bit of duplication in here. There are transformers that are being reused, or process flows that are almost identical to each other being reused in many different ways. And we want to try and resolve that where possible. And also try and understand where some of these connections are going to and from to be able to trace them. So this one goes over somewhere here. I can't be sure whether this one does go into that target there, but it's a little bit of a challenge, as you can see, and we wanted to try and resolve that to make it more workable. So a few things I'm going to go through here. One is that it was very important to understand what the process contained in terms of volume of transformers, what type, and how many custom transformers were being used. And the reason for that is that when you go and look at revising a process, the world has often moved on a little bit, and certainly FME has moved on a little bit. I often get asked about backwards and forwards compatibility with FME, and the situation is true that if you write a workspace in FME 2009, as this one was built, and then run it in a later version of FME, the result should be the same. The whole point is that you can author a process in a version of FME and then it will continue to work in exactly the same way. And in this scenario, we want to be able to try and help ourselves a little bit by hopefully revising some of the processes and bringing in transformers that might have changed, or more efficient approaches that have been brought into the product. There is a concept of transformer versioning, for example, which I would urge you to go and look at. Use that search term, transformer versioning, on FMEpedia, and go and have a look into that topic. But we managed to extract an understanding of what transformers were in this process, and I can assure you I didn't sit and count them. I wrote an FME process to carry that out. There were too many transformers in the workflow to be able to physically count them, over 900 of them. So we needed to understand what was being used and try and understand what the themes were and why when we were unpicking the process. So let's go and have a look at how we did that. You can actually write an FME workspace to read an FME workspace. This is a really handy technique. Why you might want to do that is to understand what management or maintenance issues you might have in the future, what steps you're going to have to take to keep it up to date. I'll show you a few scenarios there in a moment. If there are any obvious performance enhancements that might be able to be made, so certain transformers receive or have received in history certain rather significant upgrades to make them more performant in one way or another. So you may want to check to see if a particular transformer is being used, so that you can swap it out or change it, and understanding whether there needs to be any changes to a particular methodology that you've deployed. In this example, we wanted to know what changes we'd managed to achieve before and after. So it was a comparison of the workflows and what difference we'd made. Things that we can extract are things like how many transformers there are, which transformers are being used, what names they are, what versioning is being used, and what readers and writers are being used and deployed in the workflow. So let's go and have a look at this process. I'll just start up an instance of FME, and I have a workspace prepared for us to go and take a look at. So it's called the Workspace Summarizer. And you can see that it uses a text line reader. So this is a text reader, and it actually reads a .fmw file. So the text reader is very handy for reading text-based content. Those of you that have tried this will know that an FMW file is actually visible, readable in Notepad. You can see there's quite a lot of content in here that tells you about that process and what's in it. This sort of harks back to the old days of mapping files, when you had to handcraft this code prior to Workbench being around. As a result then, because this .fmw file is essentially a text file, we can use the text file reader and just change the file extension of the file type that we want to read, and that will consume the content of the workspace into this process. So if I connect an inspector at this point and just prompt and run it and tell it to read that workspace. Well, let's pick another one rather than one we're actually using. So let's try this dynamic schema here. Try that one instead. There we go. And then it puts out a report to summary.txt, and I'll put that into the same directory that we've got here, and run that. So what should happen is that the summary file should appear in here when we come around to writing it out, which I'll show you in a second. But you can see that I've disabled the link, which means that the content goes straight to the inspector. So the contents of that FMW file will now come in line by line into the inspector. So this is all of the text content in there. So now what we can do is useful things like use an attribute exposer to expose the attribute FME base name. That effectively gives us the file name of the FMW, which means that you could read more than one FMW at a time to be able to process that data through this workflow. The variable setter then allows us to put the name of that file into a variable, because we want to pick that up and bring that back into the workflow later on. So we're parking that value as a variable, which we will grab again shortly. The string searcher is the important part of this. Then it looks for strings that look like this: hash exclamation type equals. And if we get a string or a line that matches that, it will filter it in this direction. Anything that doesn't match will go in this direction, and effectively that means that there is a workspace that contains no transformers, because that type tag is indicating a transformer that's included. I've then included a message logger, and the message logger allows me to embed a blue warning into the log that tells us that there's no transformers in the workspace. This message logger is a custom transformer that's available on the FME store that was built by us last year. It gives you the option of creating a number of different warning types, and behind the scenes it uses TCL to create proper logs, log messages in the log window here. So what we can do then is, if we disable the link at this point, connect an inspector and run that. Now it'll run on the same process and show us all of the lines that contain information about different transformers, and there we can see the transformers that are included in this process. So this ability gives us the capability of analysing what we've got. We can then search for that text and throw it away with nothing. Do the same to clean up the suffixes. Keep any attributes that we want. So we want to keep the base name and the text data, and then we want to calculate some statistics. And we're doing that in two ways. One option here is to calculate the volume by transformer, and up here we're calculating the volume by the actual workspace itself, total transformers. So effectively summarizing that content, styling and designing some of the attributes, you can see that in a few places we're effectively defining some sort parameters, and here this is the string concatenator in action. It says that there is a total of this many transformers in this file, and it includes any custom transformers that are in the process. So if I just prompt and run this, run it on that FMW, and get my summary text file out at the end here, you can see that the TXT arrives, and then it gives us a summary of that workspace. So in this case there's one feature type extractor, 2 inspectors, 4 area builders and 4-area calculators. And this process can be expanded to understand what version of each transformer is being used, and also what readers and writers are being used as well. So it's a handy technique to analyze your existing processes. So, just moving on a little bit to looking at how we tried to understand what the results were of each workspace and make sure that we didn't break anything with the process, was effectively using FME as a test harness. This is the wiki definition of a test harness. Tells us how the testing process is carried out in software testing. A test harness or automated test framework is a collection of software and test data configured to test a program unit. And we use varying conditions to monitor the behavior and the output. Now, effectively, we had an FME process that existed, that was being used in production and was being run upwards of 4,000 times a day. We could not break that process and start producing a different output. So effectively what we did was to take examples of the features that we were processing and build an archive of them, read those through the old process and produce the output that we needed in Personal Geodatabase, read those same features through the new revised workspace and create some output features, and then use FME to analyze those processes and identify if there were any differences between those results from each workspace. The change detector transformer was principally used in this workflow to be able to identify what the differences were. The change detector is a great little transformer. I urge you to go and have a look at it. There is also a custom transformer called the update detector, which is available on the FME store for you to download. And that transformer also adds on the ability to find out records that have been updated through a feature's life cycle. So this test harness effectively allowed us to benchmark one workspace against another. And FME checked and tested that the process was okay and that we were producing the same results. So, in order to make sure that you can see the wood for the trees, we've got a number of techniques I want to focus on now, and some articles that are on FMEpedia that I would urge you to go and have a look at. The first capability that we used in the process to try and make it a little bit tidier and easier to understand was dynamic schema mode. One of the reasons for that is because in the original workspace you can see that there are a huge amount of feature types on the left hand side of the process which are coming into the workflow, giving us lots of these complicated lines that we have to work out where they're going and why. It can, when you're working with complicated data sets with large and involved schemas with multiple layers of data, multiple feature types in them, you can end up quite quickly with a workspace that has quite a few feature types on the canvas. There are simpler ways of managing this. And the tip that I'm going to show you now is to use dynamic schema mode. When you add a workspace, you have the option, create a workspace, you have an option of defining a static schema or a dynamic one. And I'd urge you to go and have a look at the FME Evangelist article here, FME Evangelist article 54, which is a little bit dated now, but it still is an extremely good document that takes you through the point of dynamic and what it does. It's written by the evangelist himself, Mark Ireland, who is one of Safe Software's employees. So highly recommend you going and looking at Evangelist article 54. So this capability gives us the ability here to make the workspace much tidier, going from these many feature types on the left here to a single input feature type. And the trick here is to use a transformer called the feature type extractor. It allows you to really tidy up the process and it also allows you to take common layers of data, whether that's layers from an Ordnance Survey dataset or layers from your own asset database or your asset layers in multiple shapefiles, for example, pass them all through the same feature type in the workflow, put them through common transformers to carry out common operations on them, like perhaps uppercasing a whole bunch of attributes on all different layers in your data, and then filter those features off in different directions to carry out different operations on certain feature types or feature classes. Here, the feature type extractor is the key transformer that we're talking about, and I'll show you this capability now. So let's just dive over to Workbench and go and find a prepared workflow. So it's only partially prepared this time. There we go, there's Workbench. So in normal operation you might add a reader to your workspace. Here I'm going to define a master map reader. So I'm going to read in a GML file. You can see I just dragged and dropped the GZ file, and FME automatically recognised the reader type that's required. Make sure that you're happy with the parameters that are being that are defined on the reader by default. And if I choose the individual feature types option, I get a new dialog that pops up that tells me which feature types would you like to expose into the workflow here. Well, this is master map topography data, so I might want cartographic text, I might want topographic area, line and topo point, and to bring those in as features on my workspace. Now you might then want to carry out common operations on each of these transformers, like perhaps removing certain attributes, so you might put in here something like an attribute keeper and do this to all of your individual features, and decide which attributes you want to keep from each one. Now the point here is that actually it would be more efficient and simpler to in this case add your reader, but rather than having an individual set of feature types, have a single merge feature type. That does two things. First of all, it defines a merge wildcard on the reader to allow us to let any feature type, so cartographic text, topographic area, boundary line, all of those layers could make their way out of here. But importantly, on this second reader that we've just added, we have a feature types to read parameter that's been exposed. If I double click it, you can see in here that now at runtime I get the option to choose which layers to read. So if I just delete my features from the other workspace, which will delete the from the other bookmark, which will delete the individual feature types, connect an inspector, prompt and run. Feature types to read allows me to say, well, let's go and get cartographic text and only read cartographic text into my workspace. So now dynamically in this process I can choose what data to read out of my input without having to read it all. And here you can see over an OpenStreetMap backdrop we can see a little bit of master map cartographic text, which will show as soon as the web connection there has allowed it to render. There we go. So if I prompt and run again, we can choose this time to perhaps go and get one of the topo layers. So let's go and have topo line and topo point and bring those in instead. So it gives you that flexibility at the beginning of the workspace to decide what is read into the workspace and is actually managed and handled at any one time. Here we've got the topo line and topo point, and then we've got the ability to do common operations keep only the attributes that we want. And the principal transformer to use here is the feature type extractor, because the beauty of this transformer is that it will now tag every individual feature with the layer that the data came from. Here, feature type is the layer, so that will contain, we run this now, and I'm choosing to group by that feature type attribute so that we can see that we now have a layer in here called topo line and topo point. We can turn them on and off individually. Turn that background map off for a moment, and you can see that that attribute that we've just created now contains an attribute called topographic line. This one has an attribute called topographic point, and that will allow you at a later stage in the workspace to add a tester or a test filter or an attribute filter to filter data off in different directions in your workspace. So it's a very handy technique for managing the flow of features through your workspace. It also means that obviously your workspace can look a lot tidier and be a lot simpler to try and manage and maintain. It gives you the benefit, the knock-on benefit of being able to reduce the number of transformers you can use, because often if you have multiple feature types, you think that you need multiple transformers to manage those. So this is a genuine portion of the workspace that we've been looking at, where data is, well, a list is exploded, a whole bunch of attributes are renamed, and some attributes are created. And in this case, all three transformers rename exactly the same attributes. The same list is exploded. The only difference here is that an attribute is created and set to a different value. So we want to try and see if we can resolve that by forcing features down a much tidier route if possible. So in this kind of scenario, if we just open up a workflow, what we're aiming to achieve is something that looks a little bit more like this. Incidentally, this is not wrong, it's just not optimal. For small workspaces it's fine, you can get away with this. Multiple feature types, in this case these are data sets that contain polylines, so we take each set of polylines and construct them into polygons and then calculate the physical area. But because these data sets here are pretty much identical, the only difference is that they come from a different MIF-MID file in this case, there's no reason why we can't open the reader with dynamic schema mode, allow each one of those files to pipe its way through this workflow, this single line, extract an understanding of the file name of where the data came from, and then build all of those lines collectively and calculate their areas collectively. This portion of the workspace does exactly the same as this portion of the workspace with a lot fewer transformers. So it's an attempt to make the workflow more efficient, more performant, and much easier to maintain. The workflow that we've seen also had quite a lot of duplication in the workflow. So I've referenced the requirement to try to get like operations carried out on all features at once where possible, and then if you have unique operations that have to happen to certain features, so perhaps you only have a few point features in your workflow that you need to style in a particular way, well, you filter those off using a geometry filter and send the point features to another part of the workspace and style those individually and then route them back into the workflow. In this workspace, 20% of the data, the features, had an attribute called level, and there were 21 case changes used to turn that attribute into uppercase. This was replaced with just one string case changer. So in that case it was just a requirement that you could use one transformer as a result of using dynamic schema mode and changing every attribute that arrived called level into uppercase. The bulk operations are also handy. If those of you who have used FME for a little while haven't spotted a couple of transformers, that are prefixed with the word bulk, then I highly recommend you going and have a look at them. The bulk attribute renamer is an extremely handy transformer because it has a number of different operations on it. You can define the ability to take all attributes, or some attributes, I'll go for all, and I could add a prefix, add a suffix, remove a prefix or suffix, do a regular expression replacement, string replacement, or a case change. So if I wanted all of these attributes to be uppercase, they are now uppercase. Prior to this transformer arriving, it was necessary to add a renamer and individually rename each attribute, which you can see takes a little while and is prone to error because you might miskey something. So just to be aware that every now and again new transformers come along that give you significant efficiency changes. The bulk remover equally allows you to remove certain attributes in bulk. So expression to remove might be, in this case, version, which means that any attribute that has the word version at the start will get removed. So if you've got attributes coming from particular locations, that can be with certain prefixes, that can be handy to tidy up your attribute set. The workspace also included quite a bit of Python. Python is extremely handy, but if you can avoid using it, then I would. There are a lot of transformers that do very similar things to capabilities that people have used Python for in the past. The reason why it exists there is because lots of developers want to be able to integrate with FME, and Python is a very handy tool to allow that, programming language to allow that. It also allows you as a developer and a non-FME user to use some of your Python code in a process that allows you to move data between environments using your existing Python capabilities. But there's examples where using Python perhaps isn't the best approach. In this scenario, there was a number of date values that looked like this, where the original author had used some Python to turn this date string into this one. It meant that somebody who was observing and looking at this workspace in the future, who didn't know how to work with Python, would find it much harder to understand what that part of the workspace was doing. A simple string replacer was capable here to effectively search for hyphens and replace them with nothing, but a date formatter might also be a handy transformer to take a look at, to reformat the dates. And as an aside, there are a lot of date-related custom transformers available to download that I'd highly recommend you having a look at. A number of them are available to calculate, for example, the difference between certain dates. To understand if you have date A and date B, how many days different is between the two. Calculating new dates as well is a very useful requirement. Several transformers have appeared in recent months to manage dates. So I'd recommend you looking at those. Custom transformers then, as I've referred to them several times during this session, are really containers for regular transformers. What a custom transformer allows you to do is to take a complicated part of your workspace, make it look simpler to somebody who might want to use a portion of your processing, your capabilities, and it means that they don't necessarily have to understand the complexity that is behind that workflow and behind that custom transformer. It makes your workspace look tidier, and it's exportable as an FMX file so that you can share it with colleagues. So I'd recommend you having a look at different types of custom transformer. If I just open a workspace and search for the message logger, for example, this indicates that it's available to download, and we've got a slight name conflict because I've already downloaded it. So let's go for another transformer like this one here. There we go. That's making a direct connection to the FME store, downloading the FMX file, and it's available for us to look at. Generally, you can edit these things, so if you right click on them, choose edit, it will open up the workspace that's behind the scenes, and you can see that this transformer has got an HTTP fetcher in it, so it's actually posting off to the web to go and get information from the GeoNames service. So very handy transformers sitting available on the FME store that people have built little custom workflows in. If you go and have a look at the FME store itself, that will allow you to browse without necessarily an FME installation on a certain machine. So if you go to fmestore.safe.com, you can see all of the different workflows, transformers and formats that are available for you to have a look at over there. And we've made a few of them as value-added resellers ourselves. So if you were to search for one spatial in the FME store, you can see that there's a number of different services here. There's the message logger that I showed you earlier on with a description of what it does and what the terms of use are for that transformer. FME 2014 gives you a bit more capability around custom transformers. If someone gives you a workspace that contains a custom transformer, FME will automatically go and download it from the store for you. Obviously that assumes that you have a web connection available, so that's important, but it will go and download it and embed it in the workspace immediately for you. Certain capabilities around custom transformers have been improved, so if you delete a custom transformer from your FME canvas, then it will delete the definition from your workflow. You can bulk embed or link all of your transformers in a workspace. The important thing there is that because a custom transformer can ultimately be exported to an FMX file, a shareable resource, that means that if you link to that shareable resource in your workspace, and effectively that means that if somebody changes the FMX file, then your FME workspace will reflect that change. If you embed the custom transformer, then any external changes will be ignored. Effectively, it's local to the FMW file. So custom transformers are a bit more of an advanced concept. If you're a new user to FME, really the main takeaway from this is that there are lots of users of FME out there that are doing some very weird and wonderful things in some cases and some extremely useful things in other cases, and making those transformers available for you to download. So the take home is that you might not necessarily have to build a portion of a workspace to do a particular job. Someone's probably done it for you already. So do go to FMEpedia and have a search for the kind of thing that you're doing, or log in to the FME community and join in with the chat conversations that are going around different topics in the FME community. And I'll give you a URL for that shortly. There is now support for versioning in custom transformers. There is ways that they can be connected and disconnected and renamed and embedded and managed much more simply. I won't go into the detail of that in too much detail, but again, if you go and refer to the FME Evangelist article 121, that's an extremely useful article that describes some of the recent changes to custom transformers. Custom transformers were used heavily in this workspace, 255 times all in all, but interestingly only 14 unique transformers, but they were just used over 200 times. So there were some clear efficiencies that could be brought to the workflow there. Largely the problem was around the fact that the personal geodatabase had constraints applied to it. So effectively what that means is that the file format that we were writing to would not allow certain input to arrive inside that file. So features would get rejected from the output format if we didn't manage those inside the workspace. In this case, the custom transformers that were defined had quite a bit of embedded Python. Effectively, they were looking for null values and then either throwing those attributes away or setting them to a certain value. FME 2014 takes a lot of those problems away. The necessity to use those transformers was immediately diminished because the null attribute mapper transformer allows you to manage nulls in a much more manageable way. There is another FME article, that FMEpedia article, that takes you through all the different types of nothing that there are, but certainly you'll notice that there are quite a few really. A string that is empty is very different to a null in database terms, and an attribute might just physically not exist on a feature. So depending on what you want to do, you might want to see if an attribute is null, or if it's empty, or if it's missing completely, and then you might want to set it to a different value. Perhaps if it's null, you want to set it to an empty string. If it's an empty string, you might want to set it to a particular value. A very handy mapping transformer. As I say, those transformers were used many times. We managed to reduce it so that only 5 custom transformers were used 12 times in the workflow. Schema mapping, an involved topic, but another portion of that workspace was that a significant number of those transformers in the workflow, and I mean a significant amount, 211 attribute renamers were in that workspace. That actually meant that if the attribute structure of any of the incoming or outgoing data sets changed or needed to be changed, somebody would have to open up the workspace, search for the attribute that was in question, and manually change it. And that's just not a sustainable approach. For this kind of volume schema mapping, and by schema mapping I'm referring to things like changing the name of the layer that data is written to, changing the name of attributes that come from a source environment and are written to a target environment, adding and creating new attributes in a workflow. All of this can be managed with one transformer called the schema mapper, and it's an extremely handy transformer for doing data migration projects. Effectively, what it allows you to do is to take your attribute mappings that are hard-coded in the process, and let's just go and see if we can find one. So here's the original process, and if we go and have a look for an attribute renamer, so there's one there. And in this case you can see that only 2 attributes are being renamed, but if we take a look at this one here, you can see that the same 2 attributes are being renamed at this point and at this point, and most likely down here as well. So that indicates that if one of those attributes needed to be changed, so for example if contract ID needed to be changed to something like contract ref in the target, then you would have to do that several times in this workspace, which isn't a very helpful capability. So what we actually want to do is move away from that concept, use the schema mapper and embed attribute changes in an external resource. What this allows you to do is to say, for the layer administrative group, the source attribute in the source environment is boundary status, and we would like to change that to a new target attribute called admin unit status. So that's what it's going to be referred to in the target environment, in the target format. So this mapping technique means that you can give this CSV file, in this case, to anybody who knows about the data and knows about the schema itself. They don't have to be an FME user. And then FME just uses the schema mapper to reference this CSV file, and any incoming attributes then get renamed to what they're supposed to be in the outgoing environment. So it's a much more sustainable approach to managing attribute mapping. Again, schema mapping is well represented on FMEpedia, worth going and have a look at some of the content over there. Really, just to start concluding this session and wrapping it up as we're drawing close to the hour, is just around documentation. I can't overemphasize enough how much you should document your processes. It's a very tedious part of writing any kind of process, but you will definitely benefit from it in the long run. And the important tip I'll give you here is not just documenting what you're doing in your FME process. Please document why you're doing it. Describe exactly what you've done, but why you've done it and why certain features are set up in the way that they are. Because if you refer back to this workspace in 2 days or 2 weeks or 2 years, you'll want to know what the subtleties or the nuances were with the data that meant that you had to go and take it through a particular routine. It'll allow you to understand that in a much better way. Here you can see that you can right click on a collection of features and add a bookmark. You can add annotation around features. If we bring in the workspace that we're looking at here and just zoom in on this this portion here, you can see that if we wanted to add a bookmark around here, we can just bookmark it and say this exposes attributes because we need to use them later. So simple annotation, and you might want to add another bit of annotation that describes the attributes that are actually being exposed in here. So let's just take one of those and drop that into here. And we could put a table into here that described all of the different attributes that we were dealing with if we wished. So we could have a number of different attributes that we might want to describe, so etc. So describe those values. So we've got a full complement of capabilities around annotation now, and this is all new to FME 2014, and it really allows you to fully document your workflow without the need to supply extra documentation around individual processes. As I said, hyperlinking, tables, styling, full annotation around the processes to take your descriptions to the next level. Making sure that you have workspace properties described, so what the workspace is for, what usage it should be used for, who's done any editing on that process. So you can see that if we dive over to this workspace here, you can see that the workspace properties are defined. It shows you some of the detail and some of the content and any dependencies that are in here, so which CSVs are required to be read in for schema mapping, and any legal information that you might want to include in here. It's just around full documentation of the workflow. The other thing that happened in FME 2014 that really helps us is to understand what transformer descriptions we've got for each transformer. The help is in there, was in 2013. You click a transformer, it shows you the help. Now if you click a reader or a writer, you get straight to the readers and writers manual to allow you to see all the detail about the individual formats that you're working with. To conclude then, you can see that we took a large workspace and made it into a slightly more compact one. Those of you looking at this might think actually they both look as complicated as one another, but once you start looking at the detail of this workflow, you can quickly see that it completely describes what's going on in the workflow. There is significant reduction in volume, and really it's contained into very focused tasks that are happening in the workflow, and where necessary some features have been split out to be managed independently, but here this whole section replaced a significant part of this workflow that was extra duplication, the same thing happening in every portion of the workspace. Just to give you some top-level statistics to indicate what some of the benefits were, completely depending on the machine and the environment that you open the workspace in, but it took anywhere between 2 and 6 minutes to open the workspace, the original workspace, and now it's a little over a minute in some environments. File size vastly reduced, 75% reduction, and that translated into 64% fewer transformers in the workflow. So this sort of proves that as you grow your knowledge of the FME product, you can start to make more elegant and more performant workflows. So if you have workflows or processes that you've built in previous years that are carrying out production for you, there is the possibility to bring in performance savings in time to allow those processes to not just run faster, but also be simpler for you to maintain if you have to make changes to them. The beauty of going through this process meant that the workspace was then owned by the Ordnance Survey, because they had gone through this process and had managed the documentation side of the workflow as well. So when we handed it back to them, they could manage and update it in a continual way as changes to the base map happen over the next few years, with new products coming from the Ordnance Survey all the time. So I'll refer you to a few resources that I'd like you to take a look at. Some of the things in here around different products. So go to safe.com and have a look at the detail on their site. There are specific URLs. So FMEpedia, for example, if you went to the topic FME Server, you can find out about the FME Server product in detail. The same is true of FME Desktop and FME Cloud. OneSpatial.com/FME takes you to some of our detail, and the OneSpatial group channel on YouTube is where you can see YouTube videos around these webinars, and this one will be up on YouTube in the next few days. If you go to fmepedia.safe.com, that's a very helpful location to go on springboard into all of these other resources, like the knowledge base, which has over 1,000 articles to help you understand exactly how to do certain things. Join in with the FME community and collaborate, ask questions, answer questions. Join in over there. There's thousands of people registered with the FME community. Several blogs that include tips and tricks. Have a look at the FME channel, which is Safe's own YouTube channel. There are now hundreds of movies, how-tos and webinars over on that site. And feel free to follow us on Twitter, at OneSpatial and at Safe Software, to interact with us individually. But for now, I'd like to thank you very much, and I hope that you've picked up some tips and tricks for how to make your workflows more efficient and include a little bit more best practice in your design of your workflows. I appreciate today's topic covered some advanced techniques. This was a session to give you a flavour of some of those capabilities, and hopefully if you're a new user, you can see some of the capabilities that you can build up to as you start working with FME in a little bit more detail. So, thank you all very much. We're going to sign off shortly, but we're going to hang on for a little while. There's a few questions coming in, so I'm just going to refer to a few of those now. So, couple that have come in through the chat window whilst we've been talking. One of them was, is it possible to stop a workspace being opened up in Notepad? So that's referring to the fact that effectively an FMW is a text file. A text file is, you can open it up in Notepad, the FMW file as required to have a look at the content, as I did when we were analysing that workspace's transformers. The answer is yes. You can stop it from being read in detail, and that's by password protecting the workspace. So if you find a workspace that you've got and go into the workspace parameters and have a look under advanced, you will see that there it is, workspace parameters. You've got a parameter called password. If you double click on that, you can define a password for your workspace, and effectively that applies a level of encryption to the FMW file. You can still open it up in Notepad, but you can't see the detail of what's going on in there without knowing the password. Another couple of questions. Question, how much faster is the new workspace in percentage? It completely depended on the volume of data that was put through, because effectively it's a checkout process. You could check out a very small rural area or a very dense urban area. But performance differences that we were seeing was in the region of 30% difference on the whole, which is a good chunk of time. Actually, the other significant performance difference was in the opening and closing the workspace, because if a number of small features were exported for just a small area that needed some update, so a very small geographic area was being checked out, it still took the process to, it still required the FME process to spin up on FME server and open the workspace. Took 3 or so minutes to do the data extract, and then it had a few minutes to close down that job. So it was a little bit more inefficient than it needed to be on that front as well. The only other question that I can see that came in is about transformer versioning. I did refer to transformer versioning in the session earlier on there. How to turn it on and off? Well, you'll notice that if I hover my cursor over this transformer here, the attribute exposer, there we go, you can see that it says it's version 0. On the attribute keeper we have version 2, and that's in the tooltip. To turn that setting on, if you go to Tools, FME Options, go to Transformers, you can see Show Transformer Version in Tooltip. I'd highly recommend you doing that. I suggested you go to FMEpedia to have a look at transformer versioning and what that means, but in a nutshell, transformer versioning means that over time transformers will change name. So for example, the grepper transformer, if you search for the grepper, that's what the transformer used to be years ago. You can see it's an alias name. It's now called the string searcher. So if I search and add the grepper onto the canvas, we actually get the string searcher, because that's what it used to be called. You can see that is version 2 of the transformer. So it's been revised. That might mean that it had a new a series of name changes, but more likely that there are different parameters or different capabilities in that transformer. If you add a transformer in FME 2009, you will get the current version of the transformer. If you open that workspace up that was written in 2009 in FME 2014 and open that up in FME 2014, the old version of the transformer will still reside in that workspace. So if you then want to update it, you can go in and remove the string searcher and add in the latest string searcher that is in the new workflow, and then test it. So I do recommend testing, because some transformers, when they get revised, also get extra capabilities and may do subtly different things to your workflow. So but transformer versioning is a really interesting topic to go and have a look at, and it's how you can manage and upgrade your workflows. So hopefully I've answered all the questions that came through in that session. I'd like to thank you all for attending this one spatial webinar on efficiency and best practice techniques for using FME. My name is David Eagle. You can reach me on that email address, and I'm over there on Twitter. But for now, thank you all very much, and goodbye.